Welcome back. In this video, I would like to run through an example or two of graphing piecewise defined functions using GeoGebra. Before I get started on that, I'm going to do an example, just pencil and paper, to see if we can't review the concept a little bit. Okay, so this is a so-called piecewise defined function. So this function has actually two separate rules. We use this rule on the first line if our input value is less than 1. And we're going to follow this other rule if our input value is greater than or equal to 1. So just to note here, if I were to evaluate, let's say, f of 2, well, I got to look over here at my rules. 2 is greater than or equal to 1, so there's my output right there. No computation whatsoever. F of 1, well, it meets that condition, so f of 1 is still going to be 4. Let's do something like this. F of negative 6. Well, negative 6 is, of course, less than 1, so we use this rule. So negative 6 minus 3, so f of negative 6 is negative 9. Okay, so we remember that each input is going to correspond with exactly one output. And the rule that you use to find the output depends on these conditions over here. So let's think about the graph of this piecewise defined function. Okay, so I'm going to draw a set of axes right here. Okay, so this is not really part of the graph. I'm going to draw a little dotted line right there, and that's at x equals 1. Okay, so this side of the graph is going to look like y equals x minus 3, because if x is less than 1, and that's what this portion of the xy plane is, this is where x is less than 1, the graph is going to look like y equals x minus 3, and we know what that is. That's a that's a line. Okay, y-intercept 3, slope 1, so we'd have something like that over there. And over here, it looks like y equals 4. 1, 2, 3, 4. Okay. Okay, so there's kind of a jump in the graph. Remember that the dotted line I drew is not part of the graph. That was just to kind of help me get my bearings. If you remember from your algebra, we'd have an open circle there and a closed or filled in circle up there. Okay, so let's think about how we could do something like this with GeoGebra. If we're going to be typesetting our mathematical documents, we're going to need some way to get figures into our files, and we'll typically use GeoGebra to do that. Okay, so let's go over here. I've opened GeoGebra up, and let me do that piecewise function that we just looked at. Okay, so let me change my settings here. Give me tick marks on the x-axis every 1 unit, and on the y-axis also every 1 unit. And just give me major grid lines, and that's it. Okay, that'll clean this up a little bit. Okay, so let's do that same one. Okay, now the way that we are going to do this, I'm going to do f of x for my function notation. So f of x equals, and the command that GeoGebra uses for a piecewise defined function is if. Okay, now I'm going to need this right here. Okay, the second one down. Okay, the first one is not going to be enough for me, so we'll do the second one down. So the condition that we're looking at, well, let's switch back and look at our piecewise defined function again. Okay, here it is. We follow this rule if x is less than 1. And if x is greater than or equal to 1, we follow this rule. So the condition that we need to decide is x greater than 1 or not? So over here in GeoGebra, oh, that's a bunch of nonsense. Get rid of that. I kind of switched out halfway through, so f of x equals if, okay, so our condition is x less than 1. If x is less than 1, then, now we're going to need to replace this thing right here. Okay, then the output is given by taking x minus 3. And then this is the alternate condition here. So if x is less than 1, then you're going to use this rule right here. So if x is less than 1, then do this. If not, do this. And we decided the output was going to be 4. Okay, so I'll press enter. Let me hide this. And we can see, okay, look, I've got my broken graph that we saw in the picture that I drew by hand, right? This part is a line with slope 1 and y-intercept negative 3. It's y equals x minus 3. And this is a horizontal line at y equals 4. Okay, so in GeoGebra, the if command is used to help us draw piecewise defined functions. And if I wanted to include this in a document, I could go right up here to the menu and export the image and then download it to my computer. Now, let's look at a different example of a piecewise defined function. So let me switch over back to the document camera. Okay, let's look at an example that has maybe 3 different rules. Okay, so let's talk about something like this. So f of x equals, and let's make it, how about something like negative x? And we're following that rule if x is less than negative 3. And let's do x squared if tell you what, let's make it 1/2 x squared if negative 3 is less than x is less than 2. And then we'll make it 1/2 x minus 4 if x is greater than or equal to 2. Okay, so this is our piecewise defined function. We got 3 separate rules. If x is less than negative 3, we're going to use this first rule. If x is between negative 3 and positive 2, we're going to use this second rule. In fact, let me do that like that, just so we have all the bases covered. The way I had written it, x equals negative 3 was sort of left out. Okay, so if x is between negative 3 and 2, we're going to use this rule. And then if x is greater than or equal to 2, we're going to use the last rule, the rule on the third line. Okay, now if you saw what I did to get this function, it was if you put in your condition, what you would do if that condition was met, and then what you would do otherwise. Okay, but here we have a couple of conditions, so we can't have this set up. All right, so let me, this is a neat feature in GeoGebra. See that button there? If you want something to stay in your picture but not be visible, just kind of, I can turn it on and off that way. Okay, so let me do a new function. I'll call it g of x equals, and I'm going to start with the same thing, if, and I'll select this. So if, and let's see, my condition, my first one was x less than negative 3. So if x is less than negative 3, then, well, what am I going to do? Then I am going to compute my output by doing negative x, okay? Now, here's where we get to put in our second condition. And we're going to do that by doing another if statement. So if, we're going to put an if statement within an if statement. Let me extend this so we can see everything that's going on here. Okay, so I'm going to switch back a sec to the document camera. So your first check, you get your input for this function. Is it less than -3? If so, that's the rule you're going to use. All right? But if it's greater than -3, you're not necessarily going to do this. You still have to check, is it less than -2? That's your, or is it less than 2? That's your second check. So let's go back to So back here in GeoGebra, and I believe I had this. So g of x equals, oh, come on. And then we had our first if statement, and the condition was if x is less than -3, then our output is -x, else we have to go into another if statement, and then we're checking if x is less than 2, then we're going to output 1/2 x power 2, and now to get to the next blank that you have to fill in, just hit the right arrow key from here, and see how it highlights that? And this is going to be the last line, the last condition. We're going to do 1/2 x minus 4. Okay, and you can see here, let me get out of the way, one sec. You can see here in the graphics window we've got a graph with 3 pieces. If x is less than -3, it looks like the graph of -x. You see how that would continue. It's got slope -1. It would hit the origin if it continued, but of course it stops at x equals -3. Between -3 and 2, it looks like the graph of y equals 1/2 x squared. And over here we've got another line, and that line is 1/2 x minus 4. Okay, you can see it's up 1 over 2, right? The slope 1/2. Okay, so to deal with piecewise defined functions that have more than 2 lines, you're going to need nested if statements. You can put an if statement inside an if statement to deal with these more complicated piecewise defined functions.